These are the in-class problems that I've assigned, and I want to make sure that you have solutions to them. I really want this work done in class, so there should be no excuse given that I'm making videos to help you out here. So the velocity of the object at 2 seconds. Let's remember when we have a position versus time graph, let's remember that the velocity is simply going to be the slope. And so we shall go ahead and actually calculate that slope using the rise over the run. So let's look at this point here. This point here is 0, 0. This point here is 550. So there's two ways we could do this. We can notice that we go over 1, 2, 3, 4, 5 and up 50 because we need to read it off the graph. Or we could use the calculation and say 50 minus 0 over 5 minus 0. Regardless of how you get it, though, you're going to get 10 meters per second is the slope there. Now, when we ask what the displacement of the object is, let's just remember that's the final position. That's basically the final, so the ending point minus the beginning point. Okay? And since here we're at negative 50, and we started at 0, the displacement is going to be negative 50 minus 0 for a displacement of negative 50 meters. Next, we ask the distance that the object traveled. So, from 0 to 5, I'll use a different color here. From 0 to 5, it travels a total of 50. Then from 5 to 7.5, it goes back 50. And then it goes an additional 50 more until we reach 10 seconds. So the distance covered. And again, the way I'm reading that is I look at the vertical here, which is the position. So I go, in 5 seconds, I'm at 50, having started at 0. Next, over 5 to 7.5, I'm at the 50 mark. I go backwards towards 0, and then I go an additional 50 backwards. So the total distance is going to be 50 forwards, plus 50 backwards, plus another 50 backwards, for a total of 150 meters. Now, the average velocity is your displacement divided by your time. So that's going to be the answer to B, which is negative 50, divided by 10 seconds. So that's going to be negative 5 meters per second. Whereas the speed is the distance over the time. And that's going to be a whole 150 over 10, which is going to be 15 meters per second. Now, if we plot the velocity as a function of time in the space below, we already got that from 0 to 5 seconds, our velocity is 10 meters per second. So we can plot that right here. And you know what, just to be clear, I think I'm just going to do it like this. So there we go. I like that better. And then from 5 to 10, let's be clear. At the 10 second time right here, so at 10 seconds, I'm at negative 50. And at 5 seconds, I'm at 50. So what I'm going to do is I'm going to use this point and this point. So this is for part F. For the second part, I'm going to get the slope as negative 50 minus 50 over 10 minus 5. That's going to be negative 100 over 5, which is going to give me negative 20 meters per second for my slope here. Okay. A lot of you are saying that it's going to be negative 4. You're counting squares. You actually need to look at these numbers here. So careful on that. And that's going to be negative 20 for the graph down there from 5 to 10. So that is question number 1 on the position graph. And I want you to attempt that. So that should be problem 1 that should help you out. And I want you to take a look at problem 2 on your own. Also problem 3 on your own. And in the next video, so basically problems 2 and 3 are based on problem 1. And in the next video, I'll take a look at problem 4.